Hello, we're going to record a video for the multiple choice questions of Unit 1 International A-Level from Edexcel from 2021, the January paper. So this is what the cover sheet looks like, and without further ado we'll go straight into the multiple choice questions. Okay, the first question involves a car moving towards a stop sign at a speed of 25 meters per second. That's its initial speed. The driver applies the brakes 20 meters before the sign and decelerates uniformly to rest. Well, that means V will be 0. He stops just before the sign, so he's using up his 20 meters. Which of the following, A, B, C or D, gives the magnitude of the car's deceleration? So we want to work out A. We know V is 0. We know U, initial velocity was 25, and we know it took 20 meters for the brakes to do the work. Okay. So we're going to use V squared equals U squared plus 2AS. That means 2AS is V squared minus U squared. Therefore, A is V squared minus U squared over 2S. Well, since V was 0, we take away the initial speed squared, which was 25, so 0 minus 25 squared, and 2S is 2 times 20 given divided by 40. So the magnitude of the acceleration will be 25 squared over 40. The negative sign is just there to show that it's a deceleration. The only one with 25 squared and 40 is C, so C is the correct answer. Question 2. An object, mass 8.2 kilograms, initially at rest, the U equals 0, falls, therefore A equals G, 9.81 meters per second squared. A vertical distance of 25 meters, so S is 25 meters, or the loss of height is 25 meters. It falls through the air and has a final velocity of 20 meters per second. You don't have to do any calculations, you just got to be able to know what's going on. Which of the following algebraic numerical expressions gives the energy in joules dissipated by the air resistance? In other words, some of the energy as it converts from potential energy to kinetic energy is lost. So there is some energy loss, E. Let's call that E. So the energy loss will be the potential energy lost minus the kinetic energy gained. Okay, so if there is a difference between the potential energy at the top and the kinetic energy when it hits the ground, then there will be an energy loss. Okay, obviously potential energy cannot be less than the kinetic energy, but the kinetic energy could be less than the potential energy. We don't have to work it out, we're just going to show the expression. Well, M is 8.2, G is 9.81, delta H is 25 meters, so that's the potential energy lost. This is the kinetic energy gained, half, 0.5, you can see they're not using fractions, so we're looking for 0.5. 8.2 is the mass, multiplied by the final speed squared, which is 20 squared. So we're looking for this expression. They haven't put them in brackets. If you see this, there's our potential energy lost. Take away the kinetic energy gained, and the difference in those two will tell us how much the energy loss is from potential to kinetic. Okay, that's the first two questions done. Question 3 is a graph showing, again, about acceleration, how the acceleration of object varies with time. Well, over here you can see that the acceleration is increasing with time. Yeah? So which of the following graphs shows how the velocity of the same object varies with time? Well, it can't be A, because the acceleration is negative, because the steepness is a negative gradient. So a negative gradient means acceleration is negative. Over here the acceleration is positive, so it can't be A. B gets less steep with time. That means the acceleration is decreasing. Well, the acceleration isn't decreasing, it's increasing, so it can't be B. Here the acceleration is constant because the velocity time gradient is directly proportional. So So that means it can't be C, therefore it has to be D. You don't really need to do any more reasoning. So often the quickest route to the answer is a process of elimination. And I just realized that the top of the paper is not visible. So I just move it down. Okay. Question 4 over the page. A student measures time taken for a ball bearing to fall different measured distances from rest. So U is 0, different measured distances. This is core practical 1 in effect, in a multiple choice. So this is really good revision for those of you who've done core practical 1. The student uses his measurements to plot a graph with a gradient turning out to be equal to the acceleration due to gravity. So that's the whole point of core practical 1, is what readings would you take to be able to get a graph where the gradient is g. And that's the whole point of these core practicals, getting a straight line graph in the y equals mx plus c form. So which row of the table shows what should go on the y-axis and what should go on the x-axis to make the gradient equal to g? Well, gradient will be the change in y over the change in x, so you're not going to have to do them all. Yeah, this is s equals ut plus half at squared. We know u is 0, so this bit can go. Yeah, so this bit is 0. So all we have is s equals half at squared, where a is g, so s equals half gt squared. Now, we want to see, so if we put this on the y-axis and t squared on the x-axis, the gradient will be half g. But if we move the 2 away from this side, double each side, so this will become gt squared on the right. This will become 2s, so we multiply both sides by 2. 2s will equal gt squared. So if we put t squared on the x-axis, we put 2s on the y-axis, y equals mx plus c tells us it should be a straight line graph where the gradient in the y equals mx plus c line will be equal to the constant proportionality in front of the t squared value. And we know that this has no intercept because it should go through the origin. So this will give us a gradient of g. So we want 2s on the y-axis, and that's the only one that has 2s, and t squared on the x-axis. So B is the answer. Question 5. A student is investigating a material in the form of a wire. Which of the following properties of the wire will change if a longer wire is used? Well, this is basically a process of elimination again. Density, we know, is fixed for a given material, and Young's modulus is fixed for a given material. Breaking stress may be more tricky for you to know, but for example, all ligaments break at the same stress value. Okay, so it's basically also a fixed value for a given material. So once you know what the wire is made of, it will always break at a given stress. Okay, I know it from experience because I have torn a ligament. Okay, so the only one it can be is stiffness. And obviously if you have a long spring compared to a short spring made of a wire, then the stiffness will vary according to the dimensions of the spring. So only C varies. The rest of them are constants. Okay, question 6, just to move the paper up a bit. Two objects are traveling towards each other. This is a conservation of momentum question. And then collide. Object A is of mass 2 kilograms, initially traveling to the right. There I've drawn it 2 kilograms. A is measuring to the right. I always use right as positive, like we do in maths. And object B is a mass of 5 kilograms, traveling to the left at 2 meters per second. So I've put that as a negative. So total momentum before, sum of P is the symbol for momentum. Sum of momentum before is 6 in the positive direction, 2 times 3, kilograms times meters per second. Here, 5 kilograms multiplied by 2 in the negative direction. The negative comes out, trumps. That means it's going to move off to the left afterwards. The total momentum before must be the same as total momentum afterwards. That means it must be to the left, so it must be A or C. C is mathematically incorrect. The answer is A. Okay, that's on to number 7. So this one, we did, the question on the previous page was about Core Practical 1. Well, this one's about Core Practical 2. Okay, the Core Practical 2 is about viscosity of a fluid and working out terminal velocity. The student determines terminal velocity of a ball bearing as it falls through oil. So this is the oil. He releases the ball bearing just above the oil at point V, measures the time taken for it to fall through a measured distance. So he wants for the measurement to be made, so he wants the distance and he wants the time taken, to be able to determine what the terminal velocity is. So basically he wants to know this distance the answer is x to y, so I'll explain why in a minute. From x to y he wants that distance, so he'll know that distance, he'll time it, so he could measure it, for example, by putting rubber bands here and here, and he'll measure it to go for that distance. If it moves relatively slowly, then the time measurement will be reasonably accurate. Once you do that, that's how you do Core Practical 2, and enables you to work out the terminal velocity, and from that you would be able to determine some analysis, for example, working out the viscosity of the oil. Which 2 points should he be using to measure the distance? Well, the first one, again, is by process of elimination. I went straight for the answer, knowing that that's what you want to do. Having done this before, you want it to be in the liquid. So V is not in the oil yet, so obviously it hasn't reached terminal velocity. W is right at the top, so it may still be accelerating, so you need to give it a bit of a distance. So you want it to have gone in the liquid. And then there isn't the choice of using Z except for with W, and W hasn't reached terminal velocity yet, so D is wrong. So the only answer you can have is C. Okay, and the last 3 questions, 8, 9 and 10. The first one is, which of the following is the vector quantity? Well, density is not, kinetic energy is not, viscosity is not, they have no direction, momentum is mass times velocity, therefore the velocity component has a momentum. This is a very easy question, so you're saving time to other questions. Which of the following statements is not correct for Newton's third law pairs of forces? So this one is correct. The forces act in opposite directions. They do. So an example of Newton's third law pair of forces is that the Earth is pulling you down, and believe it or not, you're pulling the Earth up in opposite directions. The Earth pulling you down, you're pulling the Earth up. So this one is a correct statement. C is a correct statement. The forces are of the same type. Gravity is is the force between 2 masses, so the 2 forces I talk about are the same type, and the forces have the same magnitude. So believe it or not, the force of me pulling the Earth up is exactly the same as the force as my weight pulling me down. So the reason why the Earth doesn't notice it is because it has a much greater mass. So the forces do not act on the same body. In Newton's third law pair of forces, we're talking about the same type of force acting for the same type in opposite directions with the same size force on 2 different bodies, okay? Not on the same body. On the same body it would be if there's a balanced force situation in Newton's first law. Okay, the final question is about a locomotive pulling a train at a constant speed. So we don't know V, but that's a question mark. We haven't been told, it's just that we know it's constant. So the force is 8,400 kilonewtons, so you have to remember to multiply by 10 to the 3. The power, output power, is 70 megawatts, so 70 times 10 to the 6. So you do need to know, don't get tricked by these kilos and megas. Which of the following gives the time in seconds for the locomotive to pull the train a distance of 1 kilometer? So it's 1 kilometer, so we know that velocity is distance over time, so I was just playing around with it, but in fact you know that power is force times velocity, or force times distance over time, okay? Now distance happens to be 1 kilometer, but you be careful that you must make sure you remember that that's 1 times 10 to the 3 meters in SI units. So if you change the equation round, you're looking for power, and this part of it, power is equal to force times distance over time. Yeah, so if you can actually just see that time becomes force times distance over power. Force is 8,400 kilonewtons, so it's 8.4 times 10 to the 6, and the distance is 1,000 meters. Yeah, so it's 1 times 10 to the 3, and the power was 70 times 10 to the 6, so they put it as 10 to the 7 with 7, so that's correct. Only C has the correct combination of numbers. I'll let you figure it out for yourself, and that is the correct way to answer this question. And that is the end of the multiple choice questions. Hopefully you'd already tried it and you got a good score. If not, keep practicing, and I'm going to do the section B questions soon when I get a chance. So this is the first video of probably 3 on this paper, and please like it and share it with your friends so they can also see how you work out these answers, and subscribe if you want to know when the next video has been uploaded. Thank you very much for your time and for watching the video. Bye for now.